Hey guys, it's Vince. Today I want to discuss a situation that I want to eliminate before it becomes a problem with your machine, or even before you buy it. Preferably you have a good thorough understanding of what you're dealing with a metal substrate CNC chassis. Okay, when you take your chassis and it's bare and it's just a piece of metal, no electronics are attached to it, it's just a piece of metal. Once you start actually attaching the motors that draw current, and then you've got the spindle motor, which draws even more current, you're basically making an EMI antenna. Okay, all of that energy that's in that chassis will start kind of feeding off one another, and really anything that's attached to that chassis requires shielded cable. Okay, and before we even attach our shielded cable to our components attached to the chassis, you want to make sure that your chassis is properly earth grounded. Okay, this is something that's never really talked about until somebody encounters a noise problem with their machines. I get messages constantly about different things that usually are attributed one way or another to noise. So I want to just nip this in the bud and explain a way to simply ground your machine from electrical noise. It's very simple to do. It shouldn't take you very long. And on top of that, I'm going to explain the proper use of shielded cable. Okay. So first and foremost, how to ground your chassis, your actual metal chassis, properly to an earth ground. Okay, you're going to take a screw, whichever, again, diameter doesn't matter, length doesn't matter, metric or imperial doesn't matter. You're going to take a screw and you're going to get a piece of 20 gauge wire, preferably 20 gauge. If you want to go heavier, you can go heavier. I wouldn't go no less than 20 gauge. But you can go 20 gauge, you can go 18. 18 is also very good. And what you're going to do is strip the wire, and you have a choice. You can use a circle clip solder connector. You can do a Google search on that, a circle clip solder connector. And basically what a circle clip solder connector is, naturally it solders on to the end of the lead that you've just created, and it allows you to put a screw through it and hold it permanently in place on the chassis. Now, I offer those in my store. They're gold plated. If you don't want to do that, you want to go the ultra cheap route but still get the same results, I'm going to tell you that way too. Take that lead that you've just stripped from the wire and make a circle out of it. Form the leads, all those little conductors. Once you twine them together, form a circle with it. And when you form a circle with it, you're going to tin that circle in that pattern, and that will make that become a circle lead, which will then wrap around the screw. You'll insert the screw through the hole in the circle, and what that will do is then be held in place, screwed to your chassis. Okay, and what you're going to do with the other end of that wire is stick it in a wall outlet on the third prong in your wall outlet. That is your earth ground. Okay, all of your grounds in your house should be, by code, earth ground. Okay, that third prong, that one pin that goes in the middle, not the two, well, not the neutral and the hot, the third pin, that oddball that sits on the bottom of wall outlets in the US, is your earth ground. So that's the process. That's how simple it is. One lead to the end of your table and one lead into the wall outlet on the third pin. That will earth ground your chassis, and then any EMI that's present in that chassis is being dissipated properly to the ground, so it will not reach your controller and cause havoc. Any missed switches where they're being triggered by themselves, missed steps. You can get all kinds of weird wonky things, especially as tables get more and more powerful, that force of EMI keeps increasing. So you have to think overall of what you're doing and what we're building here. It looks like a modified erector set on steroids, but realistically, when you have all that stuff attached, the motors and everything, that current keeps amplifying and amplifying and amplifying, and so do the forces around it. So please take into consideration now the process. It's very simple to do. Now I'm going to give you an overview of understanding shielded cable. This article is online. It's very easy to find. I will give you a link to it. It gives you a really good breakdown of understanding shielded cable. And why I'm doing this is because a lot of guys don't realize, they think just because they buy shielded cable and they hook up components with shielded cable that they're doing it right. Let me explain one thing very clear to you. If you just connect leads to shielded cable, and you think that the shielding is working because you've connected leads to it, you are incorrect. Okay? Just because the shielding is around the cable, but you are not connecting the drain wire, which is attached to the shielding, to an earth ground, the EMI is still present, which makes that cable no different than virtually, I mean, it'll be a little different. You're still going to get some shielding, but you're not going to get near the level of shielding that it was designed for. So to properly do it, again, we're not cutting corners. A lot of guys won't do it out of being lazy. I hate to say that, but that's what it is, because it's really not a very difficult process. All you're going to do is take that drain wire, and you want to attach that drain to an earth ground. Okay? If that drain is attached to an earth ground, anything that's in that cable, any EMI that's in that cable, will be dissipated the correct way to the earth ground, and once again, it gives it a pathway, so it will not reach your controller, which can cause problems. So now what I'm going to do is I'm just going to give you a brief overview. I'm not going to go into reading this whole sermon, but the article is very, very good. Again, this is a good paragraph. Cables can be a main source of transfer for EMI, both as a source and a receiver. As a source, the cable can either conduct noise to the other equipment or act as an antenna radiating noise. As a receiver, the cable can pick up EMI radiated from other sources. A shield works on both. Now think about that, because that's very powerful right there. You can get actual noise on both the source and the receiver, and they can also radiate by themselves. So if you think about that, you really got to think in those guidelines of what we're dealing with here. You really want to eliminate this before it ever becomes a problem, because like I stated earlier in many of my videos, dealing with electrical noise on these systems is very present, and 9 out of 10 times random problems, especially with the G540, are attributed to noise. And I can't state that enough. I must get questions on home-built chassis, I would say in the essence of 10 to 20 a day, that are typically just revolving around noise issues. Okay, what they've done, what they haven't done, weird things the motors are doing, weird things the chassis is doing. Usually, again, 9 out of 10 times, it's noise related. Okay, so please pay very close attention. Right here, it states placing signal cables next to power cables can also allow power line noise to couple onto the signal lines. So why I'm saying that, I know we're not talking about power lines, but if you're thinking in terms of that, if you're doing lots of cables, especially cables inside a cable chain, you can get that bleed through as well. That's why shielded cable is absolutely necessary. Okay, it's absolutely necessary on any switch or input on a CNC router or CNC machine in general, whether it be 3D printer. I don't even care what the 3D printer or router is made out of. You definitely want shielded cables used throughout, and you want the unit to be properly earth grounded. Okay. Right now they give you a little chart here. It says noise level, noise source, and typical locations, of course, and it says high, medium, and low. I'm going to tell you right now, they state that medium is considered average manufacturing plants. Well, guys, guess what? You fall within this to the heavy. And the reason you fall within this and the heavy processing plant range is because that spindle takes a lot of current, and then on top of your motors, you're increasing the current. So let's say your motors are using 3.5, maybe 3 amps each RMS. We'll say about 3 amps, okay? You have a 3-axis mill, you're generating 9 amps of draw there total. Then you also have another 7 to 9 amps with your spindle. Even if you're using an 800 kilowatt, you might be generating another 4 on top of that. That's quite a bit of amp draw, and in a small range, on top of the fact that the entire chassis most likely, hopefully, is made out of a metal substrate, which makes it a big antenna. So once again, think about what I'm saying. It's exponential. The more electronics we hook up, the EMI becomes even greater, eliminated at its source using the proper shielded cables. The primary way to combat EMI in cables is through the use of shielding. The shield surrounds the inner signal or power carrying conductors. The shield can act on EMI in 2 ways. First, it can reflect the energy. Second, it can pick up the noise and conduct it to the ground. That is what we are doing, guys. We're going to conduct it to the actual shield, and then we're going to dissipate it to the ground. In either case, the EMI does not reach the conductors, and some energy still passes through the shield, but is so highly attenuated that it doesn't cause interference, and that's what we're saying. You're never going to get 100% blockage, but overall we just don't want it to affect anything that we're looking for with our machines to keep everything accurate. Okay? You want to eliminate the problem and do it right, and we're doing just that. Cables come with various degrees of shielding and offer varying degrees of shielding effectiveness. Now that makes total sense. I'm going to now cover with you which one to pick for your application. You can see here they have a diagram. I'm just perusing over things, so once again you can read this article yourselves. But overall, you can see how basically it shows you the diagram: radiated EMI, reflected energy, remaining energy not conducted or reflected, conducted energy in the ground. All you need to be concerned with is the shield that goes around the actual conductors and the drain wire that should be dissipated to an earth ground. Okay, now an earth ground, and I cannot emphasize this enough, is not the COM negative on your power supply. Okay, once again I'm going to state this: negative on your power supply, negative common, is not considered an earth ground. It's a negative to your power supply. You want your earth ground, and again, I'm not going into the science of this, I'm keeping it simple. You want your earth ground to go to your earth, connected some way to the earth, and again, the wall outlet in your house or your shop is the easiest way to do it. It's the fastest way to do it without getting so super technical. As long as that outlet is to code, it will be the third prong on your outlet is an earth ground. Okay, so once again, do not think that hooking your shielding drain to a negative on the COM on your power supply, negative COM port on your power supply, where you have the positive terminals and the negative terminals. The negative terminal is not an earth ground. Okay, it's a negative terminal for your positive or on your power supply. So just keep that in mind. You want the negative on, or excuse me, you want the ground on your shield to go directly to an earth ground. If you did want to attach it to your power supply, you can go to the ground on your power supply that's actually marked ground. And the reason I say that is if you're using one of my boxes, okay, I'll let you know right now, I always earth ground the unit. Your power supply is earth grounded when the third prong on your plug is plugged in. It connects it to the wall. So therefore, again, that would put an earth ground on that terminal, which means you can ground your shielding to your earth ground on your power supply, but only on the ground terminal. Okay, if you're a guy who is not doing that process, who is actually connecting it and thinking that he's doing the right thing by connecting it to a COM, a negative output on your power supply, you're going backwards. That's not what we want to do. Okay, there's a lot of problems with people misinterpreting grounds. Earth ground is totally different. Earth ground needs to go, once again, to the earth, and that's what we're looking at doing. We want to dissipate the energy properly. So hopefully this has been helpful to you. I think it's going to be helpful to most because it is confusing as hell if you're a novice trying to understand this, and people go into rocket science when it really doesn't need to be rocket science. It just needs to be done properly. Again, a shield will reflect some energy, conduct some energy to ground, and pass some energy. That's what we're looking at doing. We want to shield, conduct, and pass. Okay, I mean that's essentially what we're looking at doing. There are two types of shielding typically used for cables, foil and braid. Again, they both have their applications in CNC use, any CNC use, but for general application, foil is appropriate. Foil will work for all applications generally on CNC, except one, and we're going to get into that. And of course, you probably figured it out already. That's your spindle. Again, it covers basically what the differences are between foil and braid, and then on top of braid, there's double shielded, which is braid and foil. Okay, for very noisy environments, multiple shielding layers are often used. Most common is using both foil and braid. In multi-conductor cables, individual pairs are sometimes shielded with foil to provide crosstalk protection between the pairs, while the overall cable is shielded with foil, braid, or both. Cables also use 2 layers of foil or braid. So if you think about that, guys, when you're getting redundant shielding, that tells you just how noisy a situation you're in. I mean, that's very, very, very strong protection. Okay, and again, when we're dealing with our spindles, that's something you definitely want to do. You want to do it right the first time. The spindle generates the most noise, and I promise you, you'll thank yourself because you'll be like, you know what, my system runs perfect. Then you know you did it right. Okay, when you run into those issues, I've had guys do it and 2 weeks later start having problems with noise. They're running the machine longer, they're getting more familiar with things start changing, variables start changing, humidity levels in the shop change, and all of a sudden all the conductive principles keep going up and there's no way to dissipate that energy, and all of a sudden you run into issues. So think about what I'm saying. It makes total sense. A third approach seen in Alpha, okay, now they're going over their own product, Alpha Wireless Super Shield products, combines both foil and braid shields and protective case. Each supports the other, overcoming limitations of one. Da, 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 da. What we are looking at here, again, is their assessment. They have unshielded, which is just the conductors. You can see just the conductors inside the casing. Then you have shielded, which is the foil. It's like aluminum foil. It's very thin. And then there's the drain wire. And then here again is your conductors. And then you have both shielded, braided shielded, and also foil shielded. You'd have both. This is just braided. Braided becomes even more effective than the shield, than the foil, excuse me. And then down here, you're also getting the foil along with the braid. And I'm telling you right now, when you're in a really noisy environment, this is your best friend. With a spindle, your best friend. You will be so thankful by the fact that you'll never have to deal with noise issues. I cannot stress that enough. Now, that being all said and explained, what you're looking at here, I can't emphasize, you see the drain wire coming off. The drain wire is a conductor to dissipate all the energy from this foil or whatever shield material you're using. You would simply attach this drain to the earth ground. Now you can solder a wire to this. It is solderable, and then you would heat shrink it, of course, and then you would just put that drain attached to an earth ground, and that way you're dissipating all the energy in your wiring. Now, what you're probably saying is, well, cables are pre-made and they don't really have an earth ground attached, or at least that you can visually see, attached separately to an earth ground, and you'd be right. It's inside the plug. Inside the plug, they know where the ground is going, so it dissipates the energy that way. So take that into consideration. If you buy a DB9 motor cable from my store that's pre-made, they have inside, the shielding is grounded on a pin of the DB9, so it's reaching the earth ground. That's what you always have to take into consideration. When we're building cables, we're manufacturing, so therefore we do have to pay attention to the location of how we're doing everything. So please take that into consideration. Really think about what I'm telling you, because again, all of these details equivalent to a machine that'll be trouble-free. You're spending a lot of time, a lot of money, do it right. In practice, the purpose of the shield is to conduct to ground any of the noise that is picked up, like we just discussed. The importance of this cannot be overstated, and failure to understand the implications can mean ineffective shielding. The cable shielding and its termination must provide a low impedance path to the ground. A shielded cable that is not grounded does not work effectively. Any disruptions in the path can raise the impedance and lower the shielding effectiveness. So guys, what did we just read? This is the most important sentence right here. A shielded cable that is not grounded does not work effectively. Okay? So all the BS you've read online about, I'm using shielded cable, if you don't see that drain attached to an earth ground, guess what? Not done right. Okay? That's putting it mildly, not done right. Okay? Lack of intelligence is done through work, and you'll find out very quickly with electrical, there's a difference. You want it to be done right, and the big thing here is consistency is the difference. Okay? What one guy says works today, he may encounter problems that he can't explain tomorrow. You want to be the opposite of that. You want to be the guy who never experiences problems because he did it right the first time. So think about what I'm telling you. The proof is in the pudding right here. I'm showing you the article. Again, this article is online. Matter of fact, I pulled it up on Google in probably the first search. But covering with you and explaining it, it really, I think, it kind of hits home what this topic really should cover because of how important it is and how seldom, if ever, it's been discussed. I've yet to see a lot of people discussing it because I don't think a lot of people understand it personally. I know when I first started, I didn't understand it. I mean, I wanted to get more in depth with grounding. And, even going to school and stuff, we learn a lot about grounding, but we don't learn, in real world, what's the best way to do it with our applications. We're trying to adapt everything we're doing with our machines to make it as simple as possible. At least I am. Make it as simple as possible so I'm not hiring a bunch of people and, getting different opinions and this and that. And then again, I'm playing that same game, well, just like you guys are, of what's true and what isn't true. You want to go with the best, most valuable information. Again, you can research this. I hope you do. But you can bank on what I'm telling you. This will definitely help your machine. And as far as accuracy goes, if you're super accurate now, you never have to worry about noise ever being the problem. So please take this into consideration. Review this article. I will put a link on it. Again, this is the end of it. It's a pretty short article, but it is a great educational article. And again, it's pretty simple to understand. They're not covering too much science behind it. It's just basic. This is why we do it, and that's it. So overall, we'll do an overview real quick, brief summary. Anything that attaches to your chassis, if it's a metal chassis, whether it be a 3D printer or anything that goes to your controller in your chassis, which everything we know typically electronically connects to the controller of some sort, we want to use shielded cable. Okay, best practice, just think in general, best practice on any application, shielded cable is the way to go, especially if you're doing it properly and using it with the drain going to the earth ground, which is what shielded cable is meant to do. So in summary, you know that, you stay with that. If you're attaching extra switches, if you're doing anything. Another thing to take into consideration, okay, guys that have 3D printers, anybody who's using Arduino boards, anything, even if they're not using higher quality products, in the sense of more pro-grade products, I should say, not higher quality. Everybody has their own quality standards. Always make sure your box is grounded. And when I say that, you can do the same thing to your chassis. If you wanted to, you can do the same process, just run a ground from your chassis to your wall outlet. That'll dissipate any extra EMI, and it's just good practice. If you're getting shocked a lot in your shop, a lot of guys don't think about this. If you're getting shocked a lot in your shop, usually the humidity level is pretty low, or pretty high, I should say. If it's higher, typically you don't get it. If it's low, you'll get it a lot. Honestly, I would always ground any shop tool properly. And this, again, CNC is one thing, but any tool, ground it properly, and you guys are going to see a difference. So hopefully you guys have a good, thorough understanding now of how to do it. Once again, I was like you at one point, and that this is the way I wish somebody would have explained it, because it just makes more sense, at least in my eyes. If you do have any questions, again, I'm Vince. You can get me on eDealers Direct. That's my store on eBay. Again, I deal on eBay for your protection and mine. I'm real easy to reach. If you want me to call you or we're discussing a system, don't be afraid to ask, and we'll get something scheduled and taken care of. Thank you. Take care.